Today we will discuss about extrinsic semiconductor. As in last class I told you that semiconductors are generally it is of two types. One is intrinsic and the other one is extrinsic. So in intrinsic semiconductor the number of holes and electrons are same, and in extrinsic semiconductor generally these two will not be same, and depending upon that these extrinsic semiconductors are classified into two types, n type and p type. Now we will discuss about n type and p type semiconductor. So extrinsic means some impurity is doped, okay, or added. This process is called doping. So now in n type semiconductor what happened is, what type of impurity we add? There is a pentavalent impurity. Some examples of pentavalent impurities are like arsenic, phosphorus, antimony, these things. Okay. Now suppose this is a solid sample of silicon. So we know that silicon is tetravalent. So that means this one silicon, it is forming bond with 4 more silicon. So 1 bond, 2 bond, 3 and 4 bond. Similarly this silicon, this is also forming 4 bond, 1, 2, 3, 4, like this. Okay. Now suppose we are adding arsenic into it. So if this silicon atom and this silicon, they are removed by arsenic, then what will happen? Because we know that arsenic is pentavalent, so it can you can say it can donate 5 electrons, right? So when arsenic is placed here in place of silicon, this arsenic will form 4 bond with 4 silicons available in the vicinity, but 1 electron will remain extra in arsenic. Similarly, when this silicon is replaced by this arsenic will form 4 bond with the 4 silicon, but 1 electron will remain extra here because it has 5 electrons. So here I have given you just 2 examples, but in a crystal or in a solid there will be a number of arsenic atoms which will be added. So that means it is contributing a large amount of electron in it. So if it is contributing large amount of electron in n type semiconductor, that means this condition will not be applicable anymore, because this time the number of electron will not be equal to the number of holes, but the number of electron will be much more than the number of holes. So that is why in n type semiconductor electrons are considered as majority charge carrier and holes are considered as minority charge carriers. Okay, so this is about n type semiconductor. So this condition will be applicable here. Ne means number of electron is much greater than number of holes. Now p type semiconductor. So p type semiconductor is just opposite to n type semiconductor. So in p type we will have this condition. That means the number of holes will be much more than the number of electron, and holes will be the majority carrier here and electrons will be the minority carriers here. Okay. So what kind of impurities will be added in p type semiconductor? That will be trivalent impurity. So trivalent means, for example, like aluminium, boron, these are trivalent impurity. So suppose just like the previous one, if this silicon and this silicon is replaced this time by aluminium, which is trivalent, so aluminium 3 bonds it can form with this 3 silicon, but there will be one vacancy, right? Because aluminium cannot form 4 bond. So this vacancy is nothing but it is the deficiency of electron, which will be considered as holes. Okay, since one vacancy is there, since it has only 3 electron to form 3 bonds, so the 4th place will be vacant and vacancy of electron will be considered as holes. So that means each aluminium is contributing 1 hole. So in a solid sample there will be a number of aluminium which will contribute a number of holes in the in the solid, and as a result this condition will be achieved. So here the majority carriers will be holes and minority carriers will be electrons. Okay, one more thing, see in n type semiconductor I have drawn something here, right? So this thing is already you know that this is the valence band, this is the conduction band, there is no problem. But one more thing I have drawn here, there is a donor level. So remember that since in n type semiconductors we are getting a number of electrons, so number of electron is more here, so those electron is forming a level here. Those electron means the electrons which are coming from these impurities. those electrons are forming this level, which is called donor level. So if this donor level, if you notice, you will see that you can think it in this way, that this conduction band, it has come little down. Okay, and if it is so, the energy gap is reduced, isn't it? So why this conduction level, why we are thinking that this level has come down? Because now we have a number of electrons, and those number of electrons, they are forming this layer, this level. So this is called donor level. Sometimes you may be asked to draw this graph that show donor level and acceptor level in p-type and n-type semiconductor. So donor level is found in n-type semiconductor, which represents the electrons, or the level of electrons which are obtained from these impurities. Similarly, in p-type semiconductor, here this will be the acceptor level, and this acceptor level will be near to the valence band, because holes are generally formed in which band? Valence band. So the extra number of holes that will form one layer near to the valence band, and this is called acceptor level. Okay, so this diagram is important, this one and the previous one. So for today, this much only.